In a previous video, you learned how to find the derivative of a natural logarithm, which is a logarithm with a base of e. What we're going to be doing in this video is finding the derivative of unnatural logarithms. So at the end of this lesson, you will be able to find the derivative of a logarithmic function with bases that are not e. Okay, so we're just going to look at the formula first. The derivative of log base a of x. The only difference, remember, when we did in the previous video, we had ln x, which just has a base of e. So now we're just having the log, still it's a logarithm, but the base is going to be a. So it could be 10, 2, 3, whatever. Okay, so we're going to let u be a differentiable function of x. If we have y equals log a of x, and actually I'm going to turn this into u right now, and then I'll show you what else we could do. So if we have log base a of u, then y prime is going to equal, just like we did for the ln. If you remember, the ln derivative was just du over u. That's exactly what this one is, but we're going to have one extra step in this one. It's going to be u times ln of a, so times the natural log of the base. All right, and then just an example, if I had y equals log base a of x, my y prime would be, the u would be x in this case, so du would be 1 over u, which again was x, and then the natural log of a, whatever that happened to be. So this was just a more simplified example. This is the first formula, is the one that we will use most often. Okay, so if we want to find dy dx, y equals log base 5 of the square root of x. The first thing that I'm going to do is rewrite this problem just to make it a little bit easier. So I'm going to have y equals log base 5 of x to the 1/2, and then I'm actually going to go one more step on this one, and if you didn't notice it, that's okay, but I noticed that I can bump the 1/2 out front, so this really becomes y equals 1/2 log base 5 of x, and now I'm ready to take my derivative. Okay, since we have a log base other than 5, we're still going to use the formula du over u. In this case, my x will be my u. The 1/2, since it's a constant, is just going to tag along with us, so 1/2 times du over u. Well, the derivative of u, the derivative of x, is 1 over u, which is x, and then don't forget, when we have this base other than e, we have to attach the natural log of the base, so the natural log of 5. And now just simplifying this a little bit, if I have two fractions multiply across, I'll get y prime equals 1 times 1 is 1, and then on the bottom I'll have 2x natural log of 5. All right, number 8, I think this was, find dy dx of the log base 2 of 1 over x. Again, what I am going to do on this one, to make it easier for myself, I'm going to simplify it. So I'll have log base 2 of 1 minus log base 2 of x. We learned those properties a couple videos ago. And then from here, I'm ready to go ahead and take the derivative. So here we go, and we have logs other base with bases other than e. This first one, log base 2 of 1, is actually a constant. So when we take the derivative of a constant, we are just going to get 0 for that part. Okay, and then the next part we're going to have, this will be my u. So just like, I'm going to bring down that minus sign. Just like we did with ln, again, the derivative of log is du over u. So du would be 1 over u, and then the natural log of the base, and the base is 2 this time. So then my final answer will just be negative 1 over x natural log 2. And that's pretty much it. It's just one little extra step. So hopefully now you can find the derivative of unnatural logarithms.